Lesson 5.4 is on solving inequalities using addition or subtraction. So we've solved equations, now we're doing inequalities. Inequalities are things like they've got a greater than sign, less than, greater than or equal to, less than or equal to. That's what an inequality means. So the steps we do when we solve these are going to be very similar. Some of you are still needing a little bit of practice on showing your steps correctly. And I'm being picky on this because the problems are going to get more difficult the further we go along in math. So some people are working problems out like, well, I'm going to add 5. So let me just do 8 plus 5 is 13. And then I know I'm going to divide by 7. 13 divided by 7. 1 6/7. And they never did the steps of showing what they're doing on both sides of the equation, like we talked about. Okay? That's going to really come back and not be very fun for you whenever the problems get more complicated. So please just trust me. Do it the way I'm asking you to do it, and it'll help you later on, even if it's not your favorite way right now. So once again, the inequalities are going to contain one of these 4 signs. Okay? Inequality means not equal. So again, when you look at your signs, and we can talk about, how do I know which one is which? What's what sign? Just remember, the one that kind of looks like an L is the less than, or the less than or equal to. Okay? The little line underneath means or equal to. So, for example, this first sign is greater than or equal to. And another thing, I think I got this from a student one time, is the greater than, we can kind of make that into a G. So that's greater than, the other one's greater than. The remaining one we haven't talked about would be the less than or equal to. So look at example 1. On the airline, Raul is using the weight limit for both suitcases combined is 50 pounds. How much can Raul's second bag weigh without going over the limit? So you can see from the picture, the first bag is 38 pounds. Obviously, we could figure this out without writing an inequality. Sometimes they're going to specify write and solve an inequality. So to get practice doing that, let's do that. Okay, so the weight of the first bag is 38 pounds, and they're kind of defining their second variable here. Weight of the second bag is P. If you want to do W for weight, S for second bag, I guess they're doing P for pounds. So first bag plus the second bag is less than or equal to 50 pounds. And then to solve this, we've been doing this a little different than what the book's doing. So to solve this, what I would do is look on the side with the variable. You can see they're adding 38, or there's a positive 38 we need to get rid of. Means we need to subtract 38. We're going to subtract 38 on both sides of our inequality to keep it balanced. And then when you subtract that, you'll get 12. So less than or equal to 12 pounds, which means, like the book's showing, is it has to be 12 pounds or less. Some of the problems, they're going to ask you to graph inequalities on a number line. So when we graph inequalities on a number line, here's our different cases we've talked about. So if you have a greater than or equal to, or less than or equal to, then it's going to be a closed circle, I'm going to call it, or a filled in circle. And that's because it includes the point. It's greater than or equal to it. It's less than or equal to. The or equal means it includes that point, is why we have a closed circle there. If it's just greater than or less than, it doesn't include the point. So we're going to have an open circle. An open circle. It's not filled in because it does not include that point. So if we look at the triad, Kyoko has completed 26 hours of community service. Her goal is to complete at least 90 hours this semester. Write and solve an inequality to show how many more hours H Kyoko needs to complete to meet her goal. Use the number line to graph the solutions. Okay, so the book's doing some boxes here for us, and we can use those if you want. For solving it, after that first step, I'm probably not going to use their boxes, but if you want to use them to start out at least, that's fine. So on the left side of our inequality, we've got H plus 26. This is the number of hours that she's actually performing or completing. So the hours she's completing, she wants to be at least 90. So hours she's completing then needs to be greater than or equal to 90. Once we've done that, I'm going to show work a little different than the book for solving this. So trying to get the H by itself there, adding 26 on the side with the variable means we need to subtract 26. This is what I would need to see when you guys do these problems. Subtract 26, subtract 26. Same thing on both sides. Right now you're going to say big deal, but later on it's going to make a difference. It is going to be a big deal if you don't do it this way. It's going to be more complicated for you. Okay, so we solve that. So H is greater than or equal to 64. And then we're going to graph that on a number line. So we go to graph it on a number line. We're going to find 64. I want you to graph these above the number line so you don't have to resharpen your pencil after every time. It also makes it clearer where your answer is instead of me trying to look on the actual number line and see where you shaded. So greater than or equal to, greater than or equal to. Or equal to means it includes the point, so we're going to put a closed circle, filled in circle at 64. And anything greater than that, numbers greater than 64 would be towards the right. When you do the arrow to the right, you don't necessarily have to go all the way to the very end. If you want to, you can. This is what it's going to look like. We've talked about before also, if the variable is on the left side of the inequality like this one is, the inequality and the arrow on the end of your answer are going to look the same. So that's a way to help you remember which direction to go. Again, the variable has to be on the left in order for you to do that though. Example 2. To make us feel warmer. The weather forecast predicted the evening temperature could get as low as negative 12.5 degrees Fahrenheit. Between afternoon and evening, the temperature dropped by 7.5 degrees Fahrenheit, which was consistent with the forecast. What could the afternoon temperature T have been? So, if we have the temperature and it drops by 7.5 degrees, but it's still greater than or equal to negative 12.5, because negative 12.5 is going to be the lowest temperature. So that's our inequality to start with. And then they're subtracting, so if you want to add 7.5 on both sides, and then when you add those, you'll get negative 5. Remember, those are different signs, so it's actually, we're kind of doing 12.5 minus 7.5, which is 5, and then we have more negatives. So Now their temperature to begin with would have been greater than or equal to -5 degrees. And when you graph that, would be a closed circle at -5 going to the right. Again, if you guys put that above the number line rather than on it, makes it easier for us to read. So look at the speed limit on a road drops down to 15 miles an hour around a curve. Mr. Gerard slows down by 10 miles per hour as he drives around the curve, and he never drives above the speed limit. At what speed was he driving before the curve? And graph the solution. So obviously we could figure this out. You know, if it dropped down to 15, he slowed down by 10, we could think about what speed he was actually going before the curve. We do need to write an inequality here. It didn't say it, but we're going to do it anyway just to get practice. So he was going some speed, so we could define a variable here. So we could have something like let B represent the speed before the curve in miles per hour. So that's where we're started at, that speed. And then he slows down by 10. So he'd subtract 10 from that speed. The speed limit there then is 15. So this is his new speed we can think of. Okay? Speed before the curve minus 10. That's his new speed. If he doesn't go above the speed limit and the speed limit's 15, his new speed then would have to be less than or equal to 15 if he's following the rules here and not going above the speed limit. So then to solve the inequality, since they're subtracting 10, we can add 10 on both sides. And 15 plus 10 would be 25. So he was going, before the curve, he was going less than or equal to 25 miles per hour. They do ask us to graph this. So once we have that, in order to graph it, I'd like to see 0 on your number line when you graph these. We don't necessarily have to put every single number. Maybe if they got 25, if you want to go by 5s here or something. Less than or equal to. So less than or equal to, we could put a closed circle here, and then we would be going to the left. Sometimes in real life problems we can think a little bit about this, that he's not going to be able to go negative speed, and 0 speed is not a good choice either, to just be stopped in the middle of the road unless we have a car problem. So anyway, you could consider that, and say, well, our graph has to have an open circle here because we don't want to go 0 and we have to go in between those speeds. We're not going to get that technical with it, but if you want to, it makes sense. That does make sense to do that. And technically our discussion here, if he slowed down by 10, he'd had been going actually more than 10 to begin with. So, we could even start it there. But like I said, don't worry about all the technical details. The main thing is a closed circle going to the left whenever you graph that. Example 3, they have an inequality set up for us already, and they're asking us to solve it and graph it. So this one you can see over with the variable they're subtracting. So we need to add 1/2 on both sides. When you go to do that, we need to remember when you add or subtract fractions, first you have to have a common denominator. So 6 would actually be our common denominator here. So this would be -4/6 plus 3/6. That's how they got the -1/6 that they did. Okay? -4/6 plus 3/6. They're different signs. So we're really like subtracting them, and we have one more negative, 1/6 more negative. So then less than negative 1/6, to graph that, would be an open circle at negative 1/6 and going to the left. And again, I'd like you to put that above the number line. If you don't put all these other numbers on that number line, that's okay, but show me you know where negative 1/6 is in relation to 0 at least. So if we look at the try it, we've got a similar story here. They want us to solve and graph this. So this problem, you could say they're subtracting, so you can add 1 3/4. If you want to add the opposite there, you can, and say it's a negative 1 3/4. So I need to get rid of that by adding by having a positive 1 3/4. That's fine. Once we get to this point, adding and subtracting, we have to have a common denominator. So common denominator of 8. So that's 1 6/8. So negative 5/8 plus 1 6/8. You can just subtract those if you want. They're different signs. So that's 1 1/8. The other option would be you could change that to an improper fraction. So it's 14/8 minus 5/8 would be 9/8. And then 9/8, if you divide that out, is the same as 1 1/8. So less than or equal to 1 1/8. And then again, without being too technical here, you know, there's 1 1/8 would be there. And then we're going to have a closed circle and going to the left whenever we graph that. If you look at the do you know how number 5, Eleanor is driving below the speed limit on a highway. Write an inequality to show how much faster Eleanor can drive without going over the speed limit. So starting out, we could define a variable here. Let x represent Eleanor's current speed in miles per hour. If you want to use s, you can. Just make it like a cursive s so it doesn't look like a 5. So this, to start out with, we could have something like x plus 43.5 is less than or equal to 55. Actually, sorry, this is not Eleanor's current speed. This is Eleanor's increase in speed, how much she could increase her speed by. And then when you work that out, you'll get less than or equal to 11.5. So at most, she could increase her speed by 11.5 miles per hour. Look at a couple of problems on workbook page 68. Number 7. Beginning from a depth of 35 feet below the surface, the whale swims upward and jumps to a height of nearly 17 feet above the surface. So they want us to make an inequality to model this and possible change in the number of feet to the whale's elevation. So it's starting out 35 feet below the surface. That'd be a negative 35, and then it goes up some amount, okay, r, and then jumps to a height of nearly 17 feet. Well, so it did this, it was at negative 35, it went up however far. It's not quite to 17 feet, so that'd be less than 17. And then for solving this, actually this is a negative 35 we have to get rid of. So we would actually need to add 35 on both sides to get those to cancel. And that would be 52. And so what that means then, for part B, it says explain the meaning. So we could say that the whale went up less than 52 feet from its initial depth. And number 8, Diego's neighbors paid him to take care of their fish when they went on vacation. He spent $13 of his earnings on a book and $9 on some art supplies. Afterward, he had at most $10 left. Write an inequality for how much Diego's neighbors paid him, then solve the inequality. So he got paid some amount. If you want to do P for how much he got paid. He spent $13 and he spent $9. So he got paid and then he spent some money. So if you wanted to, you could put those in parentheses to look at how much he spent altogether. And now if he has at most $10 left, this is what he has left, okay? The amount he has left is at most $10. That means is less than or equal to $10. And then if we solve that, we can see altogether here he spent $22. If you wanted to work that out to the side first, you could, and then you could go straight to this equation. Okay, but don't just magically have a 22 that wasn't in the original problem. And then they're subtracting, so if you add 22, then P is less than or equal to 32. Means he got paid $32 or less, or he got paid at most $32. So this gives you an idea of how to solve inequalities using addition or subtraction.